So, the code isn't extremely advanced as I didn't have much time left for the programming, but I think it's pretty comprehensible. I coded everything in Visual Studio Code with the Platform.io plugin. It works pretty well, you can organize everything easily and you can commit to GitHub directly. Another thing I love is the autocomplete feature and the debugging mode. It's also easier to structure your code. And I have a dark mode. But before we start, I would like to thank the sponsor of this video, PCBWay. Now, you can sure remember from the last video about the delivery shuttle how I ended the project with a remaining debt of about 134 Swiss francs. After publishing the video, PCBWay contacted me and financially contributed to the project. On PCBWay.com, you can order your custom PCBs, assemble them, and so on. But what I think is actually pretty interesting is the CNC machining. This would have been pretty useful for the steering. But without any further ado, here's the code. Alright, structure is very important. Therefore, I worked with a lot of header files and I have tried to outsource as many functions as possible and only have the most important processes in the main file. So, Arduino code is like a simplified version of C++ and actually pretty straightforward. A simple sketch, for example, consists of a few elements. Initially, the variables are defined, then there's the void loop where settings are configured for the microcontroller. Setup is only executed once. Here, you define whether the connected parts are sensors or actuators. And then there's the void loop. Everything else is placed in this function. Back to the shuttle. What are the key concepts that need to be controlled? We have the steering in the front and back, which basically consists of 2 linear motors. We have 4 hub motors which have parameters such as the direction, the speed, the brakes, and we also have the 6 distance sensors which need to fetch some data. There is the remote, which has a maximum of 10 channels. Also, there are the headlights in the fronts, the 3 LED strips, and the alarm. There are also some other sensors such as the MPU, the voltage, and the current sensors, which weren't programmed at all. And that's it! Let's start with the main.cpp file. In the beginning, I included all the header files, the libraries, and external files that I created and wanted to use. The next thing are the 3 Adafruit NeoPixels. And after I placed the code for the distance sensors, the next thing is the setup code, which defines all the pins. Most of them are outputs. After that, the iBus RC gets initialized, which is used for the communication with the RC remote. For debugging purposes, I open the serial monitor. To set the motor speed, the motor controller needs to be controlled with a potentiometer. For this, I use a digital potentiometer which is controlled with the SPI protocol. The only thing I couldn't exclude from the main file were the LED lights. I had some problems with the NeoPixel library, but more about that later. So, the LED lights have 3 modes. They can be switched on with the front strip in white, the back strip red, or off or blinking in orange. Why only 3 modes? The shuttle is currently controlled with a remote, which only has 10 channels. The light is controlled with this 3-way switch here, which data is stored in channel 6. The same thing for the alarm, which value is stored in channel 8. This button can turn it on or off. But wait, here it says channel 7, why is that? Let's head over to remote.cpp. Here you can see how the channel values are converted, and as I have 10 channels, I made a loop to request all the data and save it in an array. Sometimes I used English words and sometimes used German words and I kinda mixed them all together, but I think it should still be comprehensible enough. The array counting starts with 0, so channel 1 is assigned to the first spot in the array. In remote.h, all the used variables are declared and initialized. The speed of the motors is controlled with a potentiometer, which means currently all motors are controlled with the same potentiometer. The speed can be controlled with this joystick or throttle here. The value from the remote control gets converted to an analog value from 0 to 255, and it gets transferred to the digital potentiometer with the SPI protocol. The 2 other functions, set direction and set brakes, both open or close an optocoupler on the motherboard. Hubmotor.h fulfills the same function as remote.h. The linear motors can either be opened or closed, or off. This is achieved with switching the power supply. That's exactly what linearmotor.cpp does, but 3 times as we have 3 linear motors. The only thing left are the distance sensors, which work exactly like the well-known HC04 distance sensors, except the ones that I use are actually waterproof. I again included all the header files in the beginning, and you have to include every library again if you're splitting your code into different files. As I'm using 5 sensors, I thought it was smart to just program a class named distance sensor, define all the variables, and add a string to later return the value of every sensor. In the main file, a new class instance is created for each sensor. In the end, you just get less code and it works somewhat more reliable. The check distance function works on the same principle as the HC04. And that's basically everything. Now back to the main.cpp file. Let's look at the void loop function. It basically gets the data from the transmitter and saves it to the array. Then it sets the light, the speed, the steering system in the front and the one in the back. It either keeps the cargo bay door closed or opens it, sets the brakes, the alarm, and corrects, if necessary, the direction of the motors. The whole thing works pretty well, except the Neopix library. If code for the light is executed, the inputs from the remote are delayed, and the functions use the data which has already been stored in the arrays from the previous call. The delay lasts up to 2 seconds, and I haven't found a solution yet, but once the LED strips are excluded from the code, everything else works just fine. There's still one thing that I didn't mention, and that's the pinout file. The Arduino Mega has 54 digital and 16 analog pins. Of course, in the software must be defined at which pin which device is connected, so the file consists only of assignments and some global variables.
So, this is and he is totally right. It is incredibly hard to make a programming video targeting people who never programmed before. Therefore, I decided to make a small PowerPoint-style animation showing the correlation between the remote and the car. But if you did understand what I was talking about before, you can just skip to this timestamp.
Welcome to your most basic PowerPoint presentation. What I was basically trying to tell you during this whole video is that I have about 5 different categories of parts. The hub, the linear motors, the lights, and the other parts. And let's not forget the remote. They more or less represent the program structures. Let's look at the hub motors. The code exists only to control certain functions and variables. In hub motors, the things that can be controlled are the direction, the brakes, and the speed. Same thing goes for the linear motors, where the 3 different motors can be controlled. We have the steering in the front, the back, and we also have the cargo bay. And let's not forget the lights. The code defines how what is to be controlled. It is, so to speak, written down in the code how to control the headlights and the LED strips. The same thing goes for all the other parts, such as the alarm, the distance sensor, and of course all the unprogrammed parts. Via 10 channels, the individual functions can be controlled. And the hierarchy looks like this. The user moves a Joy-Con or pushes a button on the remote, and the remote sets the different values. But before that, we have the Arduino that interprets the values from the RC receiver. So, this is the code for now, for the delivery shuttle. You may say it's just a giant RC car, but theoretically, the functions are implemented in such a way that they can be used without the remote. The link to the GitHub can be found in the video description. Thank you all for watching, and I hope I could resolve all questions.
Targeting people who've never programmed. Who've never programmed. Kannst abbrechen.